Hello everyone. Let's solve the problem number 307. Range sum query mutable. They have clearly mentioned mutable. So what the question says, given an integer array nums, handle multiple queries of the following types. So here this one, we have to handle this one, queries of the multiple types. That is, updates the value of an element in nums. Calculate the sum of the elements of nums between indices left and right inclusive where left is less than or equal to right. So they have clearly mentioned here left and right inclusive where left less than or equal to right. Next, we implement the numArray class. So numArray list initialize the object with the integer array nums. This one they have given. Updates the value of num index to be val. This one. And returns the sum of the elements. You can read this, right? Let's come to example 1. They have given input numArray of 135. That will give the output null and some range of 0, 2, nothing but 9, and update of 1, 2, nothing but null, and some range of 0, 2. Some range of 0, 2. This one, last one, right? Some range of 0, 2 should give us 8. So overall output we got is null 9, null and 8, right? Explanation, they have clearly mentioned numArray was new numArray of 135. So this one, it will be 9. So nums 1 to 5, they have clearly explained here, right? So the output that we have to get is null, 9, null and 8. So what we'll do, we'll try to solve this this problem by making use of the segment tree. So first, let's write the code, and I'll just try to take this example and explain. Right. So first, what is segment tree? Here, a segment tree is a data structure used for efficiently answering range queries and updates on an array. So it is it is a data structure for efficiently answering range queries and updates on an array. It allows querying and updating operations. So this is very important. It allows for querying and updating operations such as finding the sum or minimum of a subarray in logarithmic time. So the segment tree is built as a binary tree where each node represents a segment tree or range of the array, and it supports dynamic updates and queries as well. So it supports dynamic updates and queries as well. This is very important as well. So then what we'll do here, first I'll just come to the numArray, this one. Here what we will do, we'll initialize a new numArray object with a given array of numbers. So first we will store the length of nums in variable n. I'll just give let n equals length of the nums. Next what I'll do, let's save n as property of the numArray object. Nothing but this dot n equals n. Next, we will create a segment tree array of size 2n initially filled with undefined. So how can we do this? I'll just give this dot tree equals array of 2 into n of this one. Right. So after this, we will fill the second half of the segment tree with the original array elements. So initially what we did, we stored the length of the numbers in the variable n. Next, we saved n as property of this one, property of the numArray object. The third one was we have created the segment tree array of size 2n. Here 2 into n, you can clearly see, right? Initially filled with undefined. We have not filled anything. This will be equal to null, or we can consider undefined as well. Initially this is filled with undefined. So we are filling the second half of the segment tree with the original array elements. So for that, let's make use of let's make use of the for loop. I'll just give for let equals 0, I less than n. So simple. Then we will copy elements from the nums to tree starting from the index n. This dot tree iterated value of the nums. So hope this is clear. Next, we will build the segment tree by calculating sums for the internal nodes. So first what we did, we filled the second half of the tree with the original array elements, right? Then we copied the elements from the nums to tree starting from the index n. Next, in the next step, what we are doing, we are building the segment tree by calculating the sums for the internal nodes. Again, I'll just make use of the for loop. So here, each interval node is the sum of its two children. So again, I'm telling each interval node, internal node is the sum of its two children. So how can we write this in code? I'll just take this dot tree of I, this dot tree. I'll just consider I into 2 for this. Plus tree of I into 2 plus 1. This is fine. So next what we'll do, we'll come here for the update method, right? Let's focus on the update operation now. First, initially what we will do, we'll update the value at the index. We'll be updating the value at the index IDX to val and adjust the tree accordingly. In first step, we will adjust the index to the point to the current leaf in the tree. So how can we do that? I'll just give IDX this dot n. So just give me a second. I will make this IDX itself. This is fine. This dot n. Next, we will update the leaf with the new value. We can just update the leaf with the new value. For that, I'll just give IDX equals val. Nothing but we are updating the leaf with the new value. Next, we will propagate the change up to the root of the tree. I'll just make use of while loop in this case. If index is greater than 0, then what we can do, we will start with the updated index as the left child first. After that, we will start with the updated index as the right child. For both, how can we write this? Let left equals, I'll just set this one to index. And also let right equals IDX. So I hope this is clear. Next step, what we'll do after this one, if index is even, then the right sibling is at the index plus 1, right? Else, if the index is odd, then the left sibling is at index minus 1. So for this, we can simply make use of the if condition. I'll just make use of the module. If index module 2, if it is 0, then it has to be even, right? So then we'll give right equals index plus 1. So just give me a second. Else, what we will do, left equals IDX minus 1. So this is fine. Next, what we'll do, we'll update the parent node to be the sum of left and right children. So parent node, parent node will be the sum of left and right children, right? So this is simple to write. This will be just this dot tree. We can make use of math.flow here. Instead of math.flow, I'll just make use of the tilde operator. IDX by 2 equals this dot tree of left plus right, plus this dot tree. Sorry. This has to be this dot tree of right. So what we are doing here, we are updating the parent node to be the sum of left and right children. Next, after doing that, we will move to the parent node. How can we do that? I'll just give the index, just point the index to math.floor, or I'll just make use of the tilde operator of index by 2. Right. This is fine. Next, let me format this once. Yeah. So next, let's come to sum range method or sum range operation. Here what we are doing, we'll calculate the sum of the elements between indices L and indices R inclusively, right? So first what we will do, we'll initialize sum to 0 here. Let sum equals 0. Then we will adjust the L to point to the correct leaf. So it will be L plus equals this dot N. And R also, right, will also be same, right? So after this, what we'll do, we'll traverse the we will traverse the segment tree to calculate the range sum. I'll just make use of the while condition. L less than or equal to R, right? So simple. Here, if L is a child, then we are including its value and move to its parent right sibling. Else, if R is a left child, we will include its value and move its parent to the left. Left sibling. How can we do that? I'll just make use of the if condition and write. So this is simple. If L module 2, if it is equal to 1, then I can just give sum test equals tree of L. Then for R module 2, if it is equal to 0, then we can give sum equals this dot tree of R, right? So then we'll decrement the R, as I've said. So this is fine. Next, after doing this, what we'll do, we will move the L to its parent node and we will move R to its parent node as well. Nothing but we are moving L and R to its parent node. L equals, let me give math.floor of L by 2. I'll just make use of tilde operator or double tilde operator, right? So it will be L by 2. R equals R by 2. So finally, what we will do, we will return the calculated range sum. So nothing but in our case, we will be returning sum. So let me format the code and let me hit the submit. I hope this works. So reference error, L is not defined. Line number 37. So left and right we have taken. So I'll just make this one L and R. So yeah, let me format this once and let me hit the submit again. I've taken L and R, right? So yeah, the code works absolutely correct. So next, let's consider the example and try to implement the same with the code accordingly, right? So we are considering this example, right? Initially. So what we'll do, these are the inputs and these are the operations. Nothing but here, num array, update, and one more is the right sum range. Num array, update, and sum range, right? So first what we'll do, operation of this one, num array with the input 135 they have asked us. So we will first step we'll go for the tree construction. The second half of the tree will be 135. This one, where is the second half of the tree? From here. The second half of the tree will be 135 at the indices 3, 4, and 5. Right. second half of the tree will be 1, 3, 5 at the indices 3, 4, 5. Nothing but here 3, 4 and 5. At the indices, what index we are having? 3, 4, 5 index, right? So sorry, this has to be, this one has to be 1, 3, 5 at the index 3, 4. 1, 3, 5. Right. Next, the internal nodes will be 3 plus 5 is nothing but 8 at the index 2. Here we are calculating this one, right? So we are performing these operations just for the reference if you're not knowing. So what we'll do, internal nodes will be 3 plus 5, nothing but 8 at the index 2, 0, 1, 2 here. This one will be 8, right? So, and 1 plus 8 equals 9. 1 plus 8 will be 9. This will be at the index 1. So, this will be 9, this will be 8. So, final tree will be, this will at the 0th index, it will still be null itself. So, let me give n, that's enough for now. This will be null. Null 9, 8, 1, 3, 5. So, the output will be null because it's an initialization step. This is just an initialization step. So, the output will be null itself. Here, we got the output null for this one, nums array of 1, 3, 5. Next, let's move to sum range of 0, 2. Let me delete this one entirely. So, now let's come here, this one, sum range, right? Now the operation sum range with the input of 0, 2. For this one we are doing. So what we have to do, we have to calculate the sum of elements from index 0 to 2, right? They have given here. We have to calculate from index 0 to 2. They have clearly mentioned here, this one. So what we'll do, first step is tree traversal. Sum 1 from the index 3 and sum 8 from index 2. The result will be 1 plus 3 plus 5. Nothing but we will get the result 9 in this case. So 1 plus 3 plus 5. Nothing but sum 1 from index 3 and sum 8 from index 2. So 1 plus 3 plus 5 will be total, it will be 9, right? So the second step, the output that we got is we are performing these operations. So the output that we got here is 9, right? This one, null 9. So next, let me delete this one. Next, we will move to the update this one operation. So let's come here, this one, update of 1, 2, right? So what we have to do, we have to update the value at index 1. We have to update the value at index 1 in 1, 3, 5 to 2. So we have to update the value at index 1 in the array 1, 3, 5 to 2. Then how can we do that? We'll update the tree at index 4 with 2. We will be updating the index 4 with 2. Next, we will recalculate the parent node. Nothing but 1 plus 2 will be 3. At index 2, we'll update index 1 to 4 plus 5. Nothing but 8. So, we'll get the output as null itself. So, that's why I didn't show the complete operation, how we are getting that one. So, we'll get null. So, the output will be here null. So, null, 9 and null we got. So, let me delete this one. So, finally, we'll move to the next one, nothing but sum range. Again, sum range of 0, 2 from the range 0 to 2. So, we'll come here, sum range of 0, 2. Then, first what we are doing here, we are calculating the sum of the elements from index 0 to 2 in 1, 2, 5. So, we are calculating the sum of elements from the index 0 to 2, nothing but 1, 2, 5. Let's see the tree traversal. So, sum 1 from the index 3 and sum 7 from the index 2. So, the total result would be 1, plus 2 plus, sorry, so this one would be 1 plus 2 plus 5, nothing but 8. So we are calculating the sum of elements from the index 0 to 2 in 1, 2, 5. These operations we are doing. So tree traversal, nothing but sum 1 from index 3 and sum 7 from index 2. So total result would be 1, 2, 1 plus 2 plus 5. So it would be nothing but 8. So the answer is, the output that we got is 8, right? The final output that we got is, for the we have seen num array of 1, 3, 5, we got null. So sum range of 1, 2, we got 9. We know how we got 9. Again, for this one, update of this one, 1, 2, we got null. And finally, for sum range of 0, 2, we got 8. So this one, the code works absolutely correct. Right. So what would be the time complexity and the space complexity? So here the time complexity for the construction, nothing but the num array, will be big O of n. Why it will be big O of n? Because we are building the segment tree from the input array that takes the linear time. So the time complexity would be big O of n here. The space complexity would be big O of n as well. So what about, let me comment this one. And also I'll just come here. So yeah, for the update operation, what will be the time complexity and the space complexity? The time complexity would be big O of log n. Why the time complexity would be big O of log n? Because we are updating the value and propagating changes up the trees takes logarithmic time. So it would be big O of logarithmic n, nothing but big O of log n. So I'll just give time complexity of big O of, sorry, it would be big O of log n, right? Space complexity would be big O of n. So let me comment this one. For the sum range or the range sum operation, the time complexity would be big O of log n as well. Why? Because we are calculating the sum over a range that requires traversing the tree logarithmically. So the overall time complexity for this operation will be big O of log n, and the space complexity would be big O of n itself, right? So why the space complexity for three operations would be big O of n itself? Because the segment tree is using an array of size 2n, which is proportional to the size of the input array. Here you can see this one in this step, right? So this is it. And let me just give me a second. Yeah, let me hit the submit again. So yeah, this works absolutely correct. So yes, thanks for watching, guys.